Hey y'all, it's Miss Johnson. Um, what's up? We're gonna learn about use substitution and the reverse chain rule, right? We talked about it a little bit in class. It is super wacky. I'm making this video. We're gonna practice it in the assignment. Great. So first I want to hit on the integral notes so far. We have these notes, which are basically our notes about derivatives but backwards, right? And then today in class, we kind of talked about what happens if you take the integral of something that fits the pattern of the derivative chain rule, right? And the answer is you gotta do the chain rule backwards, right? So for things like this, if we've just got a function and its derivative, so f of u du, we get to say its antiderivative. Antiderivative is the integral, right? We said that integral and antiderivative are basically the same thing. Bingo bongo. Whenever we have a function with an inside function where we have the derivative of the inside, we then get to do the antiderivative with that inside function as a reverse chain rule, right? Reverse chain rule. And the important thing, the super important thing, is that we have the derivative of the inside multiplied in the equation, or in the integral, right? Need the derivative of the inside almost function. Great, let's do some examples. As always, when I'm doing math, I have my notes right next to me, right? I do my math on the computer, so I'm just Alt-Tab switching between them. If you're doing it on paper, or if you hate writing on the computer, just put it on paper right next to you when you're typing or when you're writing, right? We should always have our note sheet, and it should look like this. Okay, and then just as a refresh, the reverse chain rule is you manipulate or unsimplify the integral so that the derivative of the inside function is present. And then once your derivative of the inside is present, we can replace the inside function with u. We can replace the derivative of the inside with du, and then we can just integrate as if it's a single function, right? We can condense and use our rules to just integrate. Let's see what that looks like. First equation, first integral, we've got the integral of e to the 3x dx. Our inside function is 3x. It's inside of the exponent for e. Our derivative of 3x is 3 dx. So if we can rewrite this integral, if we can unsimplify this integral to have the derivative of the inside, then we'll be good to go. We've got dx, and we need 3 dx. So we're going to write in a 3. We can't just randomly multiply things by 3. We have to counterbalance it with a 1/3. And now we can think of this as e to the u du, right? The 3 dx gets replaced by du. The 3x gets replaced by u. And now we say, how do I integrate e to the u? I look right here. The integral of e to the x is e to the x. So the integral of e to the u is e to the u. Beautiful. Not quite finished. Move this up here. We need to replace the u with what it actually stands for. Nice. That's a finished question. Boom. So again, we manipulated the integral. So we unsimplified here. We multiplied it by 3 and divided by 3. So we didn't change the content, but we changed what it looked like. We changed the structure. And then we replaced the u's and du's to streamline our integration process. Let's do it again forever. Here, our u is 5x. When we take that derivative, we get 5 dx. We want to find a 5 dx in our equation, but right now we only have dx. So I'll rewrite this saying, I wish there was a 5 here. I can put in a 5 as long as I counterbalance with a 1/5. I now rewrite in terms of u. So rewrite terms of u. This is the unsimplify step. And now I integrate look at notes, right? 2 to the power of u. Where is that? That's this one, right? We've got 2 to the power of u, so a to the power of x becomes 1 over natural log of a to the x. Over here, we're going to get the 1/5 stays out front. 1 over the natural log of 2 times 2 to the power of u. I'm going to keep 2 to the u on top. I'm going to keep 5 and natural log of 2 in the bottom. Doom doom. And then I'm going to substitute u. U is 5x, so there should be a 5x here. That's a finished problem. Let's keep going. More examples. More math. Everybody loves it. I love it. No. No. Got there. If you have any questions on these, message me on Teams, come to office hours, but hopefully that makes sense. Let's keep going. Our inside function. If we're integrating x times quantity x squared plus 4 to the 5th dx, our inside function is x squared plus 4, just x squared plus 4. The derivative of this is 2x dx. So we're looking for a 2x dx in our equation, right? Right now we've got a 1x dx. Let me do this. So when we rewrite, first off, I'm going to put this in the front. I'm going to put the x in the back. I'm going to add in a 2. I'm going to counterbalance with a 1/2, right? So I rearranged and unsimplified. There we go. Now I'm going to rewrite with u's. It's going to be a 1/2. This is u to the 5th. And then this is du. Amazing. I'm going to use the power rule for integrals to actually do this integral. That becomes 1/2, because there's a 1/2 out front. 1/6 u to the 6th plus c. We moved this one up by 1 and divided by the new exponent. And now I'm going to sub u back in. So 1/2 times 1/6 is 1/12. And then every time we saw u, we could have instead, and should have instead, put x squared plus 4. You know what I'm going to say? That's a finished problem. Remembering not to forget plus c. Remembering not to forget plus c. Yes. Don't forget plus c. Remember to put plus c. There we go. And then last example, we've got a trig one. This is a little wacky, but when we see something like this, the inside function is sine, right? Another way to write this, the sine to the 4th is sine quantity to the 4th. So our u is sine our du is cosine x dx. We actually just straight away have that without any unsimplification. So we're just going to immediately u sub, right? No need to unsimplify, no need to counterbalance anything. This is just u to the fourth times du already. Right? We already have the derivative of the inside function there. We don't have to hustle for it. Now we use the power rule. And we say that this is 1/5 u to the fifth plus c, of course. And then we u sub back u sub, right? And get that this was 1/5 sine to the fifth of x plus c. Bingo bongo, finished problem. That's it. It's definitely something we're gonna have to get used to. It's new, it's fresh, it's funky, like somebody else said in class. So be patient with yourself. Try it out. Come to office hours if you need help. Message me on Teams if you need help. You can post on the Teams to try to get your classmates to go on video with you if you need help. A lot of options. Cool. Yeah, reach out if you need me. I will see you on Tuesday.